Hello everyone, I'm Yihong and I thought why don't I just try to make a video of me reading these slides. I think it's made by the Machine Tools Airlines for Skills. It's quite an interesting website, quite an interesting project I believe. Basically it provides like free e-learning materials for additive manufacturing or 3D printing. So that's what I think I'm gonna create a video about me like learning about 3D printing. I think that'll be pretty cool. So the website address will be posted in the YouTube description below, so you can take a look at it later on. So let us take a look at their metals curriculum for additive manufacturing. You can see that there are three main categories in this course. There's additive manufacturing units, work process oriented units, and entrepreneurship units. So I think it's going to be quite interesting. So let's just start with the first lesson. Most likely it's additive manufacturing general. So let's take a look at it. So yeah, I think I'm going to resize the screen a bit so that you guys would see the whole screen as best as possible. So let us resize it. Can stretch it a bit. So yeah, everything looks a bit nicer. Yeah, let's not squeeze it too much. So yeah. So welcome. So first things it says is, dear learners, welcome to this learning unit. In the following pages you get to use some information about this course and how is it working and how to use it. Navigate by clicking on the arrows below or through the table of content on the left hand side. Use the table of contents, which allows you to choose a topic that you want to view and go directly to a corresponding page. I should extend that so it's a bit nicer looking. Visit the chapters are highlighted in blue in the table of content, as well as the marked learning objective. If you have visited every page in the chapter, you can access the test section. In general, all the green buttons on the current page are clickable. Information about what to do on the page is displayed below. Alright, completing the test successfully, you need to complete correctly at least 80% of the exercise. Evaluation will appear at the end of the test. So yeah, you can see that the course of this, you can see it's starting, it tells you the background, gives you a bit of brief history, additive manufacturing processes, benefits and impacts of additive manufacturing, application sectors, challenges and opportunities. Can't wait to take a look at what is it about. So we're gonna click next. It says additive manufacturing is currently one of the most important fields and one that is forecast to undergo significant growth and development as one of the key processes of advanced manufacturing. Additive manufacturing, often associated with the term 3D printing, consists of a group of technologies with major innovative potential that is transforming the way in which we conceive, design and manufacture products. At the end of this learning unit, participants will be able to define the technologies, explain the backgrounds, classify the processes, mention the types of technologies, list the advantages, disadvantages, explain the applications, indicate the challenges, opportunities. Alright, that is a whole lot of things we're supposed to learn. Learning objective is an introduction to the processes, their classifications, general characteristics, and in the following units they'll be more deepened with more specific aspects of each of them. So the units is organized as follows. Okay. Additive manufacturing, also known as 3D printing, rapid prototyping, or freeform fabrication, is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing technologies such as machining. The term additive manufacturing can be defined as the fabrication of objects through depositions of a material using a printhead, nozzle, or another printer technology. The use of additive manufacturing with metal powders is a new and fast-growing industry with many leading companies based on it. Yeah, I think 3D printing has always been a pretty hot topic in the last 5 years. So yeah, many terms have been used in the last decades to refer what finally entities such as ASTM or ISO call additive manufacturing or 3D printing. The use of this term is recommended. Yeah, I think there's always a confusion between what's additive manufacturing and what's 3D printing. I'll say additive manufacturing is probably the more industrial side of 3D printing, and 3D printing is more like a general term for everything. So the background is manufacturing has been highlighted as one of the key enablers for sustainable economic growth, creating competitiveness and the long-term jobs. As an advanced manufacturing technology, AM has been identified as a key priority for manufacturing. This is because AM, often referred to with more specific term of 3D printing, is an innovative technology with potential to transform the global manufacturing industry and the European economies. Additive manufacturing could disrupt the manufacturing value chain, allowing a shift of mass production to full customization, which is why essential this technology is welcome and developed in a positive light in order to keep the European economy at the forefront of innovation. I think in terms of innovation, people are the most important thing about innovation. You can have additive manufacturing, you can have normal machining, but the people you have is the thing that's going to drive innovation, in my opinion. So that seems like all. Let's go on to AM standards and structure then. So additive manufacturing standard structure. So this is the structure by the ASTM and ISO committee. Basically, you can see that there are general standards on terminologies, data formats, qualification guidelines, system performance, and it splits up to 3 main topics: feedstocks, process equipment, and finished parts. I think in general this template is very complicated. There's many overlapping items and stuff, and it's very complicated. But eventually the standards will be created and the best ones will remain. So that's how standards are, I guess. Additive manufacturing process flows. Okay, 1, CAD based 3D model, cool. 3D file, cool. Slice layers, cool. AM systems, and part finishing, and you get the final product. Alright, cool. AM processes were largely geared towards prototyping applications in the 1990s. However, since the late 1990s, AM technologies and processes have increasingly been deployed to large scales industrial, medical, and consumer end markets. Significant developments since the early 2000s includes AM applications in the production of parts of unmanned aircraft, automobiles, consumer products, organs, tissues, printing systems. AM technology continues to improve in the speed of processing and complexity of design and the variety of material used. So yeah, you can see that in this diagram figure. You can see the first AM system, stereolithography SLA, is developed by 3D Systems. I think the CEO at that time was like Chuck House. And then first generation of acrylic resins commercialized by 3D Systems and C-Bar. Alright. Printers based on the new technologies were introduced, new resins developed for commercial use, low-cost AM system developed around the world. Technologies advanced to increase adoptions, materials developed to withstand tougher, and focus on developing capabilities to process new materials such as composites and metals. So printing of metals is where I'm actually working at. It's my interest. I think polymer printing is nice, but metal printing like brings the technology to a whole new level, in my opinion. So yeah. A brief history of additive manufacturing for metals, you can see. Foundation of EOS by Dr. Langer and Stenberger in 1989. think EOS is one of the more prominent brands of metal additive manufacturing machines for the powder bed. So you'll definitely see this company's name pretty often. Binder technology process developed by MIT, awesome. First patent describing the fundamentals of powder bed fusions, yep. I think binder jet printing process for metals is going to be pretty interesting in the future. I think it provides the possibilities of mass manufacturing, so definitely something to keep an eye on. If you want to print using the binder jet, I believe Shapeways can do that for metals. EOS introduces the EOS Sync M250, okay, and then X1 becomes exclusive licensee of the binder jet technology. Yes, definitely binder jet, definitely take note of that. I think in 1996 it's far ahead of its time. I think in the next 5 years we will probably see more of it. X1. Basic SLM patent which described the metal powder bed is filed. Archem commercialized the powder bed fusion electron beam technology. So this is the technology that I studied on for my PhD. It's quite cool. I like the machine a lot. It's very different from the laser systems. It has its advantages and disadvantages. I'm sure we will see it in the other episodes or the other lessons. Automac delivers the first commercial direct energy deposition. So Automac's also another leader or pioneer in this DED system. So you definitely see Automac as well. Just that now these days there's a lot more competition in this DED space. First metal powder bed fusion by laser machine is introduced by F&S Stereolithographic. Okay, I don't know much about this company, it's quite interesting. Trum introduced its first line of metal powder bed lasers by laser machines. So Trums is another brand of powder bed fusion metal 3D printers that you will come to know of. I think their system is known for their very compact nature and very easy to use. MCP tooling technologies, later known as MTT technologies, introduced the powder bed fusion SLM realizer. Okay, AM growth in medical and dentistry. ASTM approved first non-terminology AM standards, and lots of stuff really. First AM parts. The history of additive manufacturing is definitely being written right now as we speak, so everything's moving really quickly. So if you are interested in starting 3D printing, I think now is the best time. There's no better time to start than today. So yep. Additive manufacturing process can be used to categorize by the types of materials used, the deposition technique. So by the way of materials is fused or solidified. Processes technologies is being defined by ASTM F42 ISO Technical Committee 261. Technical committees, the process types have been categorized in the 7 areas as follows. Okay, wet photopolymerization, material jetting, binder jetting, material extrusion, powder bed fusion, sheet lamination, direct energy deposition. So you can see on the figure there's the CAD base model .stl file, slice layers, AM systems, and finished parts. So this shows you the basic process of 3D printing. Liquid photopolymer in a vat is selectively cured by a light activated photopolymerization process. So this is the oldest 3D printing technology that exists. It basically consists of a liquid photopolymer in a vat that selectively hardens or cured layer by layer by the actions of a laser or light that is activated. Activates the photopolymerization process. There are 2 processes that uses this technology, SLA and DLP. So I think this is a very interesting technology. I think you can even find such technologies for home systems. Probably cost you about $5,000 or less. I think the one that I like about this technology is probably the one that's very popular. Forgot what it's called. the machine has like an orange color and stuff. I think it's the Form 1, is it? Yeah, but this technology can produce really fine details, so definitely something to look at if you like to produce fine figurines. A material jetting process. Droplets of built materials are selectively deposited. Material jetting is a process in which droplets of built materials are selectively deposited onto the built bed to develop a three-dimensional object. This injection printing process creates objects in a method similar to two-dimensional inkjet printer. The material is injected onto the surface where it solidifies, and the model is built layer upon layer. The material is deposited from the nozzle that moves horizontally through the construction platform. The layers of the material cures and hardens with ultraviolet light. As the materials must be deposited as drops, the number of materials available to use is limited. Polymers and wax are suitable, commonly used materials owing to their viscous nature and their ability to form droplets. Yeah, I think this process is mainly done by the Polyjet brand. So I think it's a really office-friendly system, I feel. The only problem about this material jet system that it follows the traditional inkjet printers kind of business model. So basically you are paying a lot for the build materials and the support materials, because there is a lot of tuning that you need to do, because if you simply put in your own materials, you actually clog up the nozzles and it'll cost a lot of money to repair it or replace it. It might not be possible to repair it because all the nozzles are microns in size, so it's very difficult to unclog it once it's clogged. So yeah, for binder jetting as well, liquid bonding agent is selectively deposited into the powder materials. Binder jetting is an additive manufacturing technology that creates artifacts through the injections of binder into a bit of raw material powder. In each of the layers, the deposited binder droplets bind the raw materials particles and form a two-dimensional cross-sectional image. Once the layers are printed, the powder feed pistons is raised and the construction pistons is lowered. Subsequent layers is printed and fused to the previous layer by jet binding. So yeah, pretty cool. I think X1 does the metal-based binder jetting. For the polymer base, I would think the HP method, I think it's a multi-jet fusion method, works in a very similar manner to this binder jetting principle. Basically, you are jetting sort of colors and glue onto the powder, and it sort of binds the powders together and you form your solid parts. So liquid bonding agent is selectively deposited to join powder materials. Pretty cool. Material extrusion method. Materials is selectively dispensed through a nozzle or orifice. Material extrusion is a technology of 3D printing more widespread among the general publics in the so-called desktop 3D printers. For its flexibility of use and relatively ease of construction, the vast majority of printers we can find on the market uses the material extrusion technology. The process used is known as the fuse deposition modeling, but as the term FDM is registered by the Stratasys, it is also known as fuse filament fabrication, or manufactured by fuse filament. To avoid legal problems, the concept of the operation is very simple. It melts the thermoplastic in the form of filament that is deposited by the nozzle layer by layer until a process is formed. Yeah, I think this is the first time we're gonna see the first acronym of additive manufacturing, FDM or FFF. So all these companies sort of registered these acronyms for themselves, so it's very confusing when you see a lot of these acronyms and basically they are just explaining the same thing. But yeah, material extrusion method is also the method that introduced me to 3D printing. think the first brand that I knew was the MakerBot brand. Unfortunately, now Stratasys actually bought the MakerBot brand, and there's no MakerBot as far as I know now. Now it's like part of Stratasys anyway. So I think initially when MakerBot started, it started off like an open source community based kind of a brand. Now that it's bought by a more traditional company, it's becoming it's now a more traditional kind of company, I feel. So the next process is the laser powder bed fusion. Thermal energy is selectively fused into regions of the powder bed, process in which a thermal energy selectively fuses regions of powder bed. It can be made by two different sources, the laser or electron beam. A layer typically 0.1mm thick of material is spread over the build platform. A laser fuses the first layer or first cross section of the model. A new layer of powder is spread across the previous layer using a roller. Further layers or cross sections are fused and added. The process is repeated until the entire model is created. So basically, this can be also looked at some kind of like a micro welding kind of process. You're using this energy beam to fuse the bed of powders. So yeah. Sheet lamination, a process in which sheets of materials are bonded to form an object. So this is something that I don't see it so often, but I know that it's there. Maybe it's just too ahead of its time, but yeah. In this process, layers of adhesive coated paper, plastics, or metal laminates are selectively glued together and cut to shape with the knife or laser cutter. Objects printed with this technique may be additionally modified or machined or drilled after the printing. The process is performed as follows. The sheet is adhered to the substrate with a heated roller. Laser traces desired dimensions of the prototype and the cross hatches of non-part area to facilitate waste removal. Platform with a completed layer moves down out of the way. Fresh sheet of material is rolled into position. Platforms down into new position to receive the layer, and the process is repeated until the full model or prototype is prepared. Yeah, so basically this is I feel that's a very waste generating kind of process, because you are basically just layering a piece of sheet of material, and then you're using the laser to cut a cross section of it, and then you paste it on the previous layer, and then you have to spread over a new layer again, and you do the same thing. So basically you get a roll of material with a lot of holes in them, because all the cross sections are being cut out of them, and recycling them I feel would be a problem, mainly because there's adhesive. Adhesive is simply just like some sort of a glue or binding agent, so I think that would make it difficult to recycle the materials. So yeah, not too environmentally friendly in my opinion. So a process in direct energy deposition. So this one's first pioneered by the Automac company. So it's a process in which a focused thermal energy is used by materials to fuse materials by melting the materials being deposited. A family of additive technology which essentially adapts welding techniques to build up materials into three-dimensional near-net shaped parts. Geometry is created when the feedstock material, typically a wire or powder, is fed into melted by a focused energy source, generally resulting in a melt pool. As the melt pool is moved around, the wick of the molten materials left behind quickly solidifies as added material. The energy source most typically used, such as welding, arc or laser or electron beam. So yeah, I believe this technique basically you're just using a high energy beam as usual, or high energy arc, to basically cause a melt pool in your metal, and then you are simply just spraying or jetting materials into the path of this melted pool. So it either can be like powder or it can be a wire, such as like a welding. You're just pushing the wire into the melt pool, so that's sort of building things up. Very similar to welding, I'll say. In general, additive manufacturing is very similar to welding, in my opinion. So benefits and impacts of additive manufacturing. Additive manufacturing has the ability to offer significant benefits for a wide range of applications. So it gets you CAD to part, allows you to manufacture very easily, design for customization, design for function, design for lightweighting, material utilization, less pollution, reduce time to market, localized manufacturing. So tons of benefits. So as long as you want to create something, I think 3D printing is definitely the easiest way to create something these days. There are companies that provide 3D printing services, so as long as you can draw the part in 3-dimensionals and you can likely make it. If you can't draw something in 3-dimensional, you can probably find somebody to draw it for you as well. So yeah. Application sectors. Additive manufacturing technology is no longer used only for prototype. It's also used for metal part production, hence the strong growth since 2012 of additive manufacturing system sales for the production of metal parts. Yeah, so I said metal parts are the thing that I like, mainly because it's like printing plastic. It's almost, people can say it's like a toy, but when you can print something in metal, it becomes a bit more serious. It's something that can last for a very long time. So yeah, the use of additive manufacturing technology is developed in many industries: aerospace, medical, tooling, automotive, and consumer goods. Basically, if you want to create something, definitely take a look at additive manufacturing. It makes manufacturing a lot easier. So this sector begins to demand a high number of parts that improves its production process. It's an interesting sector with great possibilities. In the market industrial sector, the production of die cutting in tools and molds, the latter with ventilation channel, reduce the process time and achieve better production and quality. So you can see on the picture, you can see that 3D printing allows you to design channels inside your parts that in the past you probably couldn't do very easily. So you can design these internal voids with 3D printing pretty easily because you are creating the parts layer by layer. So yeah, it's one of aerospace industry is one of those sectors who have first opted for these technologies, making use of parts for non-structural elements. Due to the advancement of technology and materials, structural parts are also being manufactured. The sector is of high value added due to the interest in reduction of weights in small parts to achieve economic savings in the fuel. The production focuses on small runs, complex geometry, focus on new burners, and turbine components. Alright, pretty self-explanatory. Basically, the aerospace industry likes to create aeroplanes that are light and strong, so that's why 3D printing can create such parts for the aerospace industry. This automotive industry, the sector has been betting on additive manufacturing for a long time, but always focused on prototyping and rapid product development. The development focuses on a limited series and competition of vehicles, look for weight reduction. It is a sector that at the moment has very little interest, has high needs of large volumes of productions. Current technology does not have that capacity. The production is focused on prototypes for validations on new components or parts that finish in the short runs. I guess basically for all industry, 3D printing is capable of designing new parts. If your car or so is very old and it's very difficult to find the spare parts, I think 3D printing is also a very attractive option. Consumer goods and electronic sectors, it's the most important sector using additive manufacturing until recently. There's a possible development within this sector due to the wide range of toys, household utensils, This sector has on the one hand little interest since its manufacturing low volume, very high, and the product life cycle is very low, but on the other hand, given the large market and the need for product updates, they are interested on prototyping for rapid product development. The production is focused on prototypes and validations of new designs. Yeah, I think there's been pretty much a few news that I heard that additive manufacturing helps to promote innovation. Basically, it helps promote innovation because it allows people to create new products very easily. So if you have a product in your mind, it's pretty easy to create using 3D printing because the cost is very low as compared to traditional methods if you just want to create a one-off part. So yeah, consumer goods, I'll say this is always the starting because once consumers understand the technologies, then they find out some award-winning ideas or profitable ideas, and then they'll start the company, and then the industrial will pick up a bit. Health medical sectors need to manufacture unique customized pieces such as bone implants. It's a sector of high added value regarding the quality of life. Yep. Production focuses on dental prosthesis, orthodontics, medical prosthesis, in the sector where more evolution and great direct application exists, being the product provided just a prototype or also a final product. So basically the reason for this is that you are building a bone implant that's inside your body. So you can imagine that if the bone implant didn't fit you perfectly, you will definitely feel it. So you want the bone implant to be as comfortable as possible. So that means that every bone implant is unique and is customized to your own bone so that you have the maximum comfort. Either way, it's not going to be comfortable having a metal piece inside your body, but 3D printing can make it slightly more bearable. Among the other sectors with less applications to date are the jewelry sector, the architecture sector, the footwear, sports, textile, design in general. They are sectors that at the very moment have very little interest since they only make use of the technologies of additive manufacturing for prototyping. Alright, I would kind of disagree with that. I guess now these days with service bureaus and other libraries of stuff, people can actually 3D print jewelries or jewelry, something that they wear. So I won't say it's only for prototype. I'm pretty sure valuable metals can be also 3D printed, and it will be very popular, I'll say, as more people are buying stuff online and creating their own stuff. I think that's definitely an opportunity over there. So now we're on the next chapter, challenges and opportunities. That is a lot of opportunities and a lot of challenges, it seems. Different needs of additive manufacturing industrial sectors. Yeah, different industrial sectors would definitely need different needs. Modeling and simulation development. Currently, there is quite a lot of development in the simulation. You have the Autodesk, you have ANSYS, you have Siemens, and you have lots of other smaller like Magix as well. Lots of people are creating modeling and simulation for additive manufacturing. Development and testings of materials for higher performing materials. This is also a constant research topic. Everybody wants to create stronger materials. This is very important because in human history, the materials sort of define the era. So when people develop plastics, we have lots of plastic bags, everything is plastics. So it sort of defines the human era, I'll say. So if 3D printing were to develop materials with higher performing materials, I won't say higher performing in terms of materials, but 3D printing can like usher in a new era where complex designs, lattice structures, more organic form of design can be incorporated with 3D printing. Engineering, machining, manufacturing requirements for part in design and post-processing. Yes, I guess it's focusing on post-processing. In 3D printing, the parts are usually very rough, so you need to do some post-processing. A common baseline for comparability in tests between different materials and machines. Yeah, because the technology is very new, there's always going to be differences. People don't really know what's the standard thing to expect because there are tons of different companies selling 3D printers, so everybody will be slightly different. Increased understanding of new reliable materials, including better simulation and software, particular software that allows the simulation of how the product will react after curing and melting with different materials. Okay, more process simulations, that's quite common. Development of highly integrated and combined technologies such as subtractive with AM to AM. Basically, it's a hybrid. Basically, they're trying to say there's an AM plus some machining subtractive form. I think the brand that it comes to mind is either Automag, it comes with DMG Mori, and Mazak. It also has systems that does this hybrid sort of manufacturing. Focusing on industrialization of additive manufacturing technologies, development of new production systems with linked additive manufacturing and traditional technologies, development focusing on industrials of additive manufacturing with traditioning. Oh, I think it's trying to show some kind of process monitoring system. I think now these days all the systems are connected to the internet, so if you look into a dashboard or screen, you can probably see the operations of the different machines working. Developing emerging approaches, moving to micro scale, nano scale dimensions. This always happens, people are always creating new processes. Very good. Further understanding of the businesses and supply chain benefits. Yes, I think this would change slightly later once people are more confident with the technology. Then there's definitely a huge disruption to supply chain, because if you can build and you can make stuff locally, then everything is sort of a lot cheaper. But in general, I think China is still the main manufacturing factory of the world. So even though you can make it cheaper in your home country, I think the labor cost needed will still be higher in China. I think everything is much cheaper. Everything is made in such a large economy of scale that I feel everything's a lot cheaper in China. Process stability, capability, and productivity. Alright, with additional research and development, everything will become more stable. Further development of additive manufacturing technology with improved material consumption. Alright, more greener machine, that sounds good. More efficient use of expensive materials. Integration of the whole process chain, data management, in-process quality control. Yeah, sounds right. Standardizations, regulations, qualifications, and certifications. Guidelines and rules for CE marking, compliance, improved legislations. Focusing efforts on manufacturing process, on quality controls, material quality, standardizations. Considerations of regulations, IP, health and safety. Yep. Training and education. Wow, there's quite a lot, I would say. Quite a lot. Exposing the technology to a wider set of innovators, training of designers, building more best practices case, facilitating the education of people, establishing technology transfer, educating all levels, communicating through conference, growth and support networks. There's a need to look at business, address the total concept, cross-cutting, integrating activities, skills and training of multidisciplinary. Alright, so basically, yeah, that's all, right? Chapter completed, so that's cool. So test your knowledge, what to do. Test with the following exercise. You can check your knowledge. To complete the test successfully, you have to complete correctly at least 80% of the exercise. Evaluation appears at the end of the test. You will not get the direct feedback on the exercise. Test includes exercise of single choice, multiple choice, drop down, fill in the blank, word list, task. On every page, you'll be informed about what to do. As long as you have not left the page, you can change your answer. Let us hope to get a pass. Exercise 1. Please select your answer by clicking on the corresponding button. When finished, go to the next page. In which of the following process families can only metal materials be processed? So material extrusion, it can be produced by polymer and metals. And metals is the desktop metal and the Mark Forge. Direct energy depositions can only be done by metal. You get the Automech, DMG Mori, Beam, Mazak. Vat polymerization can only be done with a polymer. You can see it's polymerization. Material jetting, which is your polyjet, it can be done by polymer and metals. I think metals, you have the X-jet. X-jet can print like nano size of metal droplets. So the only process family that can be printed with metals alone has to be the direct energy deposition. Exercise 2. Yes, this is the Formlabs picture. The Formlabs, I'm pretty interested in this printer. I think it can print like polymer and ceramic as well. It's a very interesting printer. I think it costs about 5 to 6 or 8,000 in Singapore. Still very costly, I'll say, but it's pretty cool. Definitely do check out the Formlabs. To which family of processes of additive manufacturing belongs to the process of stereolithography? Stereolithography is known as the vat polymerization and stereolithography. So yep. Which is the more widespread 3D printing technology among the general public for its flexibility of use and the relative ease of constructions? So the clue is given on this picture itself. It's a Ultimaker, so it has to be the material extrusion, FDM process, or the FFF process. I'm from Singapore and I'm pretty excited that Ultimaker actually has an office in Singapore. So yeah, I think the FDM process was made widespread by a professor in the University of Bath, I believe. So he had a research project to create an open source, to create a 3D printer, and I think he made it open source, so super thumbs up to him. He definitely made 3D printing more widespread to the community and to the world. So yeah. Which of the following is not a benefit of additive manufacturing? So reduced time to market, it is because it helps speed up prototyping. Localized manufacturing, it is because now these days if you buy a 3D printer, you can actually fabricate things in your own house. So I think recently there was a person that got arrested because he bought a 3D printer and printed parts of firearm in his home, and he was actually under a ban of he cannot own or buy any firearm. But one day he printed his own firearm and he fired it in the woods, and some police heard about it and they arrested him. So yeah. Design for lightweighting, yes, additive manufacturing definitely can design for lightweighting because you can create lattice structures, especially suitable for long series. So this is definitely the disadvantage of additive manufacturing in a certain way. because when you say long series, people generally assume it's a mass manufacturing, like your fork and spoon. They are the same design, you make them for a lot of them at one time. But additive manufacturing is also capable for mass manufacturing of customized parts. There is one company that makes like dental fixtures for your teeth. So basically they make like teeth guides, and every few weeks or so you wear these teeth guides. It will help align your teeth. So, and they produce like, I'm pretty sure, thousands of these teeth guides every day. So I would say additive manufacturing is also suitable for long series of customized products as well. So yeah, I can imagine that additive manufacturing will be used to create long series of medical implants for anybody that needs medical implants, or prosthesis as well. So one interesting thing is like prosthesis. Whenever we think of prosthesis, means extra fake fingers and stuff. Basically, we think of prosthesis as to help people with missing fingers or missing body parts. But prosthesis can also help augment like your fingers. Imagine now you have 5 fingers. Imagine if I can 3D print like another prosthesis fingers, you get 6 fingers. So you actually become a bit like superhuman as well. Pretty sure that's pretty interesting. In what sector of applications is not extended for the use of additive manufacturing? Extractive industry. I think this is the one. I think extractive industry sounds like mining. Not many news on this. Automotive, definitely lots of news on additive manufacturing. I think there is a American and Hong Kong company called Divergent 3D. I think they make 3D printed, I think they make partly 3D printed cars or partly 3D printed supercars, and mainly all your general manufacturer of automobiles. I think they use additive manufacturing in some form or another. Aerospace, definitely Boeing and Airbus. And medical, yeah. So definitely the application that's not really using additive manufacturing, or something that we have not heard much about it, is the extractive industry, or probably the mining industry. Congratulations, you have succeeded. You have reached 100%. Well done, you have understood the main aspects of additive manufacturing in general. By clicking on the button, you'll be forwarded to the curriculum page where you can choose the next learning unit. So yeah, hope you enjoyed the lesson. I think I learned more about additive manufacturing as well. I think it'd be quite cool to learn on the YouTube as well. So right, cool. Once again, a big shout out to Metals, a mobile learning website. Metal stands for Machine Tools Alliance for Skills. Very cool, I guess. They have this e-learning website, which I think is pretty cool. So yep, once again, thanks very much for watching, and bye.